Looking at composition and resolution of vectors, then we shall start with vector quantities. Vector quantities. Vector quantities, and we shall say that vector quantity is a physical quantity. With both magnitude and direction, e.g., displacement, velocity, acceleration, force, weight, momentum, etc. Next, we say scalar quantity. Scalar quantity is the quantity with only magnitude, but without direction. E.g., distance, speed, time, temperature, density, mass, energy, etc. Next, we go to addition, vector addition. Then we say vectors acting in the same line. Vectors acting in the same line. Then we say that if vectors are acting in the same direction, then the resultant is obtained by adding them. Then we say resultant force is a single force which has the same effect on a body as two or more forces. Resultant force is a force which has the same effect on the body as two or more forces. So when you have more than two forces acting on the body and get resultant, so the resultant will be as if there are more forces acting on it. So the single force is what we call resultant. Then we say if they are moving in the opposite direction, then resultant force is got by subtracting them. Then that's part A. Part B, vectors acting at an angle. Then we say with the vectors inclined at an angle to each other, a triangle of vectors is used to find the resultant. The resultant given by the line that completes the triangle. Then the component of a vector is the effective value of a vector along a particular direction. Then we say the resultant is obtained by getting the vertical component and the horizontal component of the vector and then using Pythagoras theorem. And the direction of resultant is important i.e. F will look at square root of horizontal component squared plus the horizontal components of the vertical components of the forces squared. And direction tan theta is obtained by getting F over Fx. So theta is equal to tan inverse of Fy over Fx. Then LB, when getting horizontal component, when getting the horizontal component, we use cosine. We use cosine. When getting horizontal component, we use cosine. And the vector must make an angle theta with the horizontal. Must make an angle theta with the horizontal. And for the vertical component, we apply sine. And for the vertical component, we apply the sine of the angle between the horizontal and the vector. Between the horizontal and the vector. Now, let's look at the first example. Look at the first example, okay? So we have, this is the question. They are telling us that the diagram below shows forces acting on a particle, find the resultant force. So we shall say that resolving vertically, we say that we use what? Resolving vertically. Want to get the components of these forces in the vertical direction. So vertically we use sine. So we shall say that Fy is equal to. Now, this 14 has no vertical component. It is acting in the horizontal, therefore it has no vertical component. This 6 has vertical component. But then we shall apply hint. We shall apply this hint. We shall apply this, that here all of them are taken to be positive. Only sine will be positive. Only tan will be positive. Only cosine will be positive. So if the angle is here, when you are taking both tan and cos and sine, you take a positive. When the angle is here, when you are taking, it is only sine. It is only sine which will be positive. Only here it is only tan which will be positive. Here we shall have only cos which is positive. Is that okay? So we shall now say that this angle 45, which the 6 makes with the horizontal, it is in this quadrant. This quadrant, it is on the side. So it will be 6 sine 45. Then here, in this quadrant, sine is negative. Here, it is only tan which is negative. Sorry, the only tan is positive, sine will be negative. So minus this one is 8 sine of 45. So here you can get your answer as, when you use the calculator properly, you'll be able to get your answer as what? We shall get our answer as negative 1.41. Negative 1.41 newtons, okay? Then horizontally, resolving horizontally, we shall use this symbol. That is Fx. Now this one has a horizontal component which is here between this and this. So it's positive, that's 14. Then this one has horizontal component, but in this quadrant, it is cos is negative. So minus 6 cos of 45. Minus in this quadrant also, this is the cos is negative in this quadrant, okay? In this quadrant, the cos of this angle is negative. So minus cos of minus 8 cos of 45. So here we shall be able to get our answer as 4.1 4.1. Or we can even use a calculator. That is 14 minus, this is 14 cos what? Cos 45. It is 4.1. 4.1. Now let's draw the diagram showing how the forces are acting. So this one is negative, so it is acting downward. It's a negative, so it will be negative 1.41. Then this one is positive. Positive, it is this direction. That will be 4.1. Then get the resultant. This resultant, that's F, and this angle is theta. So how we get the resultant? We should get the resultant first by squaring and adding them, right? Okay, so that is 4.1 squared plus 1 point negative, sorry, plus a negative of 1.41 squared and square root. So the resultant force now gives us around, it will give us around 4.34. 4.34 Newton. Direction theta is tan inverse of Fy. Fy is 1. Now this negative shows the direction, okay? So we remove it in here, we will also remove it here. Negative shows what direction, so that's 1.41 divided by Fx, that is 4.1. So the direction theta, the theta now in this case becomes 19 degrees. Okay, so that's the number 1. We can now go to. So we have this one. The diagram below shows forces acting on a particle plane. So these are forces acting in a different direction. So we say that when we are resolving, we shall use cos of the angle of the angle which it makes with what? With the horizontal, and we shall use sine of the angle which it makes with the what? The horizontal. Then we shall also use this one. All students take chemistry. All students take what? Chemistry. So we shall now here come and say that resolving vertically, that is F, forces under vertical direction will not become. We can start with 2. 2 has no vertical component, you can see it has only horizontal component. There is no angle which 2 makes with the horizontal. That's what we are saying. It has no vertical component. Okay, because we refer to say that 2 sine of 0 is 0, not so. So we go to 4. For this angle which makes is in all of them. So that is 4 sine of 40. Then this one, it is in this one. Now, the angle which makes with the horizontal will be what? This angle will be what? This angle will be 60 degrees because this is 90, not so. So this is 30, so this will become 360. So it's a plus because it is in sine quadrant. That is 3 sine of 60. Now this one has only vertical component, but it is in the boundary of T and C. Since it's between T and C, obviously this will have to become negative. So minus 6. Because the angle which it makes with the horizontal, okay, is 90, and sine of 90 is 1. So here we shall be able to get our answer under vertical direction as negative 4.90. Negative 4.90. Then horizontal components, that's f of x. This one has 2, this is 2. Okay, the angle which makes 0, which is cos 0 is 1, okay? Then this one is positive, that's plus 4 cos of 30. Then this is negative, minus 3 cos of 60. Then this one has no horizontal component. So here our answer fx will now become, when we substitute, we get 10.03. 10.03. Then our now we draw the diagram. This is negative, so it's going downward, and this is 4.90. That's a positive, that direction. This is 10.03. Then the resultant is here. That is F, direction which makes let us get alpha. So our resultant force will be equal to square root of what? 10.03 plus 4.90 squared. So our resultant force, let us go to FR. Our resultant force will now become 11.16. 11.16 Newton. Direction, it's alpha will be tan inverse of vertical components over horizontal components. So factor is 4.9 divided by 10.03. So our direction is 26.04. 26.04 degrees. So you can say that the resultant force is, yes, the resultant force is what? 11.16 Newton at 26.04 degrees to the horizontal. The what? Horizontal. That's how you conclude. Okay. So we can move on and look at the next one. So the diagram below shows forces acting on the body. Find the resultant force acting on it. So how do we get the resultant force? We shall now say resolve horizontally. But we have to make sure that as we get sine and cos, we are getting cos of the angle which the vector makes with the horizontal. Take note of that, okay? That is the my simplest method you can use in physics here. But in mathematics, there are other methods you can use, okay? So here, resolving vertically, that is F what? Now, this 3 has no vertical component. This 2 has a vertical component, that's 2 sine. What's the angle? The 2 makes with the horizontal. This angle is what? What will be this angle? This angle is equal to what? 60 degrees. So sine of what? 60. Because this plus this, you get the equation also. Then this one has a positive. But then this one is a positive because it is in all. Then sine here will be positive, so it will be plus 6 sine of 60. This is minus because it is in tan. So it is minus 5 sine. Minus 5 sine. What's the angle 5 makes to the horizontal? The angle it makes to the horizontal is 60. Okay? This is also what? This is also 60. This is 60 degrees, okay? Then this one is also minus, okay? Minus what? Minus 4 sine of 30. So when you use a calculator, my dear friends, you'll be able to get the answer as what? You'll be able to get 0.598. 0.598 into this. Then resolving horizontally, that's fx. 3 has a horizontal component. Because if you say 3 cos 0, it remains as what? 3 cos of 0 is what? Is 1. Then this one has positive plus 2 cos of what? Is it 60? Yes. Then this is minus what is the sine? 6 sine of what? 60. Then here it is minus 5. Cos of what? When cos of the angle 60. Okay? Then plus what? Plus 4. Cos of what? Cos of the angle to make the horizontal is what? 30. So when you substitute properly, you will get something 1.964. 1.964. So the resultant force, you can draw the diagram if you want. But anyway, let us draw the diagram. So this is a positive. That is 1.964. Then this is a positive. It is up. This is 0.598. Then resultant force is here. FR, the angle it makes is delta square theta. So I shall say that horizontal force. Remember, this is, you can copy the diagram like this. So this is Pythagoras theorem. So we shall have square root of what? 1.964 squared plus 0.5980 squared, okay, under square root, and the resultant force will now become, using a calculator to get 2.053 newtons, and direction theta will become tan inverse of the vertical component, which is 0.5298. Then for horizontal is 1.964, giving us our answer as 16.9 degrees. So you conclude and say the resultant force is 2.053 newtons acting at 16.9 degrees to the horizontal. So we can now have exercise. So this is exercise. The first one shows the forces acting on the particle. As you can see, the direction is, and I say find the resultant force acting in the system, number 1. Number 2, you have a mass, you have forces acting shown in this diagram. So you have to ensure that you look for these angles, because you should look the angles met with the horizontal. And after getting resultant force, you'll be able to get acceleration, because force is equal to ma, senior to work, remember that work. Then you have the same thing. If this is 45, what is this? What angle does this one make with horizontal? So you need to get the horizontal angle, and then after that you resolve both vertical and horizontal and draw the resultant diagram, and then finally get the resultant. So this is exercise that when you have gone through previous unit course, and you read through this exercise and see how you can easily do this exercise. So that's what about the resolving of the forces.